good morning dear students. This is a chemistry class. Today in digital chemistry classes, we are going to talk about the reactions in solutions. It can be say in the different way also, like ways to express the concentration of solution also. The ways to express the concentration of solution mean what? Let me tell you. Most of the chemical reaction in the laboratory are carried in solutions form. Okay, so actually in case of reactant, these are if in case of reactants are solids, and that their molecules or ions are so closely packed in space that there is hardly any movement in them. Therefore, the chances of their coming closer to react and quite remote. However, the solution molecular motion is quite free, and the same is true in the ions in the ionic solids also. They can radially take part in this reaction. We must try to know about the different ways in which the amount of substances present in the solution are expressed. This is known as concentration. The concentration of binary solution in which two components are present, it can be expressed in number of ways. So today we are going to discuss those number of ways how we can represent the concentration of solution. Okay, so let's understand first what is the meaning of solution. The meaning of solution is, as you can see on the top, solution is the solute. Solution is the solute plus solvent. What is solute? What is solvent now? In junior classes we have studied solute are those components which is present in the smaller quantity. Solutes are those substances which present in the smaller quantity, and solvent is those substances which present in the larger quantity. Or in different way you can say solute is that which dissolve inside the solvent, and solvent is what? Which allow the solute to dissolve within it. Okay, so what is the meaning of now if we will say the concentration? Concentration is the amount of substance present in a solution. The amount of substance present in the solution. Dear students, let us simple example. Suppose you are making a salty water or lemonade. So salt you are adding, pinch of salt you are adding in a water. Suppose if you added 10 gram of salt in a 100 ml of water, so the water will be a little bit less salty. If you are now increasing, you are dissolving now 20 gram of salt in a water, it will become more salty. If you will add 50 gram of salt in 100 ml of water, it will become more and more salty than the previous two examples. Okay, so this is called, we are going to increase the concentration of NaCl in water. So that concentration is called amount of solute dissolved inside the solvent. Okay, so there are two ways to measure, to check that concentration. One is qualitatively, second is quantitatively. So first qualitatively is two type, dilute and concentration. Dilute is in which solute is present in very low amount than the solvent. In concentration, solute is present in a large proportion than solvent. Okay, so but most of the time what is happening in chemistry, it is very difficult to get clear idea about the concentration through the qualitatively. So we will move for the quantitatively. Quantitatively mean quality and quantity. Quality is its quality, it's talk about the quality. Okay, and how mean quality is how. Okay, and quantity, yeah, you can say quality mean what is inside this, and quantity number, so it is how much, yeah, how many. Okay, so quantitatively we can represent this concentration in different, basically 5 ways. One is mass percentage, volume percentage, second is part per million, third is mole fraction, fourth is molarity, fifth is molality. As in plus 2 class, it is formality and normality also. Okay, so first we will talk about the mass percentage. Mass percentage is what? You can see mass percentage is simply mass percentage, it is weight upon weight percent. It means that solute is also in weight, solvent is also in the form of weight. Okay, and volume percentage is what? Where volume upon volume percent. It means that mass is also in volume and solvent is also in volume. Third is becoming mass upon volume. It means that now solute is in weight form and solvent is in the volume form. Okay, percentage is multiplied by 100. So part per million is 10 raised to power 6. In million there are 6 zeros, so 10 raised to power 6. We will multiply the part of component, mean how many solute dissolve in how many solution, multiply by 10 raised to power 6. Okay, next is mole fraction. Fraction, you will get all the hint from the word fraction. Suppose percentage, million, fraction. Okay, so number of mole of component upon total number of mole of all the component in the solution. Like if suppose we will represent it simply with the Na. Na is solute, A is solute. Suppose we will write, we are going to find out XA, sorry, not XNA, XA is equal to Na upon Na plus Nb. Okay, so this is the simple way to represent the this mole fraction. Okay, now it can be represented in the form of X, so XA plus XB. total fraction of solute plus total fraction of solvent is always equal to 1 unity. Okay, this is the law. So if so many solute is there, so many solvent is there, still their sum will come 1. Okay, we will do some of the numerical related to this. Next is molality and molarity, which is very important. If you see the molality is number of moles of a solute, dissolved in 1 liter. This 1 liter you need to take care. 1 liter is written, and here per kg is written. You can see difference, 1 liter per kg. So in case of molarity, R-I-T-Y, molality, L-I-T-Y, this is different. In case of M-O-L-A-R-I-T-Y, molarity, capital M is the denotation. We can denote molarity with the help of capital M. So it is number of mole of solute dissolved, total volume we are writing here, volume you can see. And in case of molarity, nothing is different, it is same, like number of moles of solute dissolved per kilogram. So this is the difference. So let's see next from here, what now in detail, expressing of concentration of solution. Expressing of concentration of solution with the help of this, the composition of solution can be described in expressing its concentration. The latter can be expressed either qualitatively and quantitatively, that we did. Qualitatively, we can say the solution is dilute, relative very small quantity of solute, or it's concentrated, relative very large quantity of solute. And the concentration of solution may be defined as the amount of solute present in the given quantity of solution. Getting my point? Amount of solute, think, amount of solute present in the given quantity of solution. Okay, so there are several methods to which we can describe the concentration of solution. There are, so first is mass percentage. The first one is mass percentage. Okay, the mass percentage of a component in a given solution is the mass of component per 100 gram. Mass percentage of a component in a given solution is the mass of component per 100 gram. It means that mass percentage, to calculate mass percentage, we should have simple formula: mass of component in a solution upon total mass of solution multiply by 100. Mass of component in a solution divided total mass of solution multiply by 100. So let's, WB is the mass of solute and W is the mass of solvent. So if we need to find out the mass percentage of WB, okay, so how we find out? WB upon WA plus WB into 100. This is the general formula. So now let's take an example. Calculate the mass percentage of benzene. If benzene is a solute, carbon tetrachloride is the solvent. If 22 gram of benzene is given and it is dissolved in 122 gram of carbon tetrachloride, the mass of solution will be mass of benzene upon mass of tetrachloride. Here you need to take care. Most of the students, they are doing here wrong. They are writing simply solute upon solvent. It is not solute upon solvent, it is solute upon solution. The solution will become solute plus solvent. So benzene plus tetrachloride is the solution, and the mass of benzene is 22 gram, mass of tetrachloride is, carbon tetrachloride is 122. So when total will do, it will becoming 144 gram. And in 144 gram, mass percentage of benzene is mass of benzene upon mass of solution into 100. 22 upon 144. You know what is 22? Mass of benzene. What is 144? Mass of total solution. Multiply by 100. So it become benzene is present in this percentage, 15.28%. Dear student, do the same numerical in your notebook. Try to calculate and then try to get, is it correct or wrong? Okay. Second, mass of percentage of carbon tetrachloride. Simple way. 122 is the mass of carbon tetrachloride. 144 is the mass of total. Multiply by 100, it become 84.72%. Here you need to cross check. You need to add all the mass percentage of each component. It should be equal to 100. Okay. So this is mass percentage. Second is volume percentage. In volume percentage, again, the volume percentage W upon W. The volume percentage is the volume of component per 100 part of volume of solution. The difference is only there we are using weight, mass word. Here we are using volume. Okay. Formula is still same, and the example also will be in the same way. Here solution containing liquid are commonly expressed in volume percentage. For example, 35% volume upon volume we will write. There we will write 35% of mass upon mass. This is different. Mass by volume percentage. This originated from upper two. Mass percentage, volume percentage, when collectively we will take, it will come mass by volume percentage. Okay. Mass by volume percentage, mass of solute upon total volume of solution into 100. A 10% solution of sodium chloride means 10 gram of sodium chloride is dissolved in 100 ml of water. So part per million is the next. Part per million is the one is solute of is present in a trace quantity. The concentration of expressed in part per million is called part per million. As I said you, 10 raised to power 6. But now next, which is mole fraction, this is very important. It is the ratio of number of mole of one component, it can be solute, it can be solvent, to the total number of mole of the all component, it is the solution. Okay, it can be expressed in the form of X. So how to calculate it? With the help of this formula. Mole component of a one, suppose we are taking solute, so mole component of solute can be taken X solute is equal to X solute plus X solute upon X solute plus X solvent, and mole fraction of solvent is X solvent is equal to N solvent upon N solute plus N solvent. This is very simple. XA is equal to Na upon Na plus Nb, and XB is Nb upon Na plus Nb, and in general XA plus XB is always 1. Okay, and if we have so many solutes, suppose in a solution, we will write Xi is equal to Ni upon N1, N2, N3, N4, Ni. So this is very simple mathematical summation. Ni upon summation Ni. We will write sum of all the Ni's. Okay. So like this way, one numerical is given here. Example: calculate the mole fraction of benzene in solution containing 30% of mass in carbon tetrachloride. It means that if solution is 100 gram, mass of benzene is 30 gram. Okay, and the mass of tetrachloride is 70 gram. So let's see in next how they have done this. So it is same question. Molar mass of benzene, we have discussed what is the molar mass of benzene. You need to calculate this. Molar mass of carbon tetrachloride, this. Now given mass is there. Given mass is 30 gram for benzene and 70 gram for carbon tetrachloride. And the molar mass is 78 gram per mole for benzene and 154 for carbon tetrachloride. So after calculation, we are getting this much mole. It means that how to calculate mole? To calculate mole, very simply, percentage is given. So it is given mass upon the molecular mass. Given mass upon molecular mass. If you have suppose given mass, if suppose in this question percentage is given, so we can convert percentage into gram by taking 100. Now given mass is there, so we need to calculate molecular mass. Given mass upon molecular mass is equal to mole, or mole fraction need to calculate. So simply if xi mole you are finding the mole of benzene upon total mole of solution, it is giving this much value. And similar with carbon tetrachloride, 1 minus the value of this xb, value is coming 0.54. But when you will calculate this both sum, you will do sum, it should come 1. Okay, so this was all about the mole fraction. Now next is molarity. Molality. This is very important, and most of the questions are coming from this. Molarity and molarity, there are some differences. Molarity, RITY, molality, LITY, molarity, capital M, molality, small m. Okay, molarity, volume, molality, mass. So it is defined as the number of mole of solute dissolved in 1 liter of 1 cubic diameter of the solution. It is function of temperature. Like molarity is to define molarity, number of mole of solute. It is same in both the cases, but here volume, there it will be mass, kilogram. Okay, so how to calculate mass? Simply one more factor very important. Molarity varies with the temperature. Molarity can change with the temperature. Molality cannot change. The molality is independent to temperature. So unit of molarity is gram per gram mole upon liter. Okay, gram mole upon liter is a gram mole upon liter per liter. It is clear. So this is the example. Calculate the molarity of each of the following. Just go through this example. You will come to know what is the this is also the part of the same numerical. This is molarity. Now molarity we will talk. As molarity we discuss, similar with molarity, number of mole of solute per kilogram. Now number of mole of solute per kilogram, here it is kilogram. The same way we will find out, if suppose question is there, if the density is same lake water and it contain 92 gram of sodium ion per kilogram of water, calculate the molality. The when question will come like this way: number of mole in 92 gram of sodium ion. Now 92 gram is the mass, and this is the molecular mass. 4 mole is there. Now 4 mole when you have, the mass of solute is 1 kilogram. So 4 upon 1, it will come 4 mole per kilogram. Okay, so these are some of the practice questions. Just pause the video and go through each question and one by one solve these questions. Some of the questions are already solved, but some of these 10 questions you need to do today in your notebook. Okay, so this is all about for today. Hope so you understood. Some of the questions I will going to share you in the PDF form also. Try to do that, dear student. This is one of the most important topic, so that's why I am taking it seriously, and you need to see, and if any doubt is there, you can call me and you can ask me anytime. Okay, so this is all about today. Take care yourself, stay home, stay safe, and give my regard to your parents also, and try to self motivate you day by day. Okay, thank you. Have a nice day.